Hello, everyone out there in YouTube land. This is Charlie Barley with perhaps maybe the best video that I've ever created because I have done it. I figured out the flatbed algorithm that flows with the game. It's taken quite a while, 3.5 years for me to finally come up with it. I came up with it maybe 2 months ago, but I think I've refined it now. And of course, I'm using it for my mentorship program, which I will talk about later. However, what I want to do is show you and talk to you guys about algorithms, okay? And why this algorithm, this flatbed algorithm, completely defeats the game. And the game has zero thing it can do to you or me in playing such. One of the things about algorithms, and you'll see, and I'm gonna show you on these spreadsheets how these algorithms are used and why you consistently see upward strings or upward profit. I'm going to break all this stuff down in a second because previously what we were doing, we were using algorithms, but the algorithms that we were using were steeped in permutations. What I mean by permutations is that we were fighting the computer against a threshold of patterns. For example, red, red, blue, blue, red, red, black, black, red, red, black, black. Well, how many times does that go? What's the threshold? How many times does that ever went straight, right? That's the concept of a permutation. Red going 27 times straight. That's the maximum that's ever been recorded. That's a threshold. And there are many systems, all the systems that I've sold previously were all steeped in threshold based progressive style play, which you needed multiple strategies to be able to play consistently and win consistently. The thing about it is that it works. The flip side of it is that it takes some time. Okay. And one of the biggest things that for any developer, any person who's ever tried to quote unquote beat the game, one of the things we've always wanted to do was create a flatbed system, because if you have a flatbed system, then the fight is no longer about progressions. Like, the game can't beat you because you're fighting against a threshold or you're fighting against a permutation that your money can't out pay for. So, you got a $5 minimum, you have to increase to 10, 20, 40, 80, that type of a thing. Well, many of the strategies that we have, despite the fact that we have progressions, we were still able to beat the game, or to really give it a good whooping before we got struck with a high progression. Well, in this case, what I've done is figured out, like, right here, these are spins, right? So let's say the ball landed right here on 10, 35, 0, 15. Excuse me, guys. Hopefully it's still working. Okay, there we go. 15, 14, 12, 35, 1, 1, 16, so forth and so on. Well, these numbers flow in a certain pattern. If you go back and look at old videos of mine, you'll see where I'm able to predict slightly where the patterns lie. And as you can see, all this is coded to kind of detect where the patterns are flowing, so forth and so on. So it puts that there automatically. But what we would do is, to make things easier for us, instead of following the numbers in terms of flat betting, what I did was I looked at the dozens that they were landing in. And so we would do a flat bet, say in one dozen for say $50, right? And let's say if we're wrong, instead of making a progression, the algorithm that is right through here, do this, there we go. The algorithm that is found inside of here, of course I can't show the actual code, but it's in here. And it tells me, really, it adjusts toward the game. So whatever's happening here, this is going to show me what we should play. Okay, basically. And you'll get to know that in the program. But the algorithm is based upon what's previously happened because it's following the nature of the game. So it's able to pick up, say, like if 14 goes 14, 14 straight twice in a row, or if it goes dozens 3, dozens 1, regardless of where the dozens or the numbers lay, the algorithm is going to pick up the flow and the pattern of the game, which is why you see in all of these charts, the algorithms that I use, this is spin number 1, 3, 5, 7 down here. This is the money. These are $100 bets. But you can see the algorithm picks up and it constantly creates a positive winning progression. Here's another example where it looks like the price is right. It goes up and up and up. Anyway, so but it consistently creates a positive progression. As you can see, here's another example. It's 50 spins each. So you're looking at about an hour, maybe 45 minutes of play. Constant positive progression. And what I'm going to do is I'm going to show you, I'm going to pull up more numbers and we're going to do this step by step. But before I do that, what I want to do is show you why and talk to you guys about algorithms, because a lot of people are confused that they think you can't beat the game. And the way to, I think most people were trying to beat the game on the inside. And that's true. But the reason why you want to reshift, if you're thinking in terms of algorithms, which you should be thinking flatbed algorithms if you're trying to defeat it on your own. It's just extremely hard to come by. It's a lot of data and a lot of study. Not saying you can't do it. It's just to get the right algorithm to make this happen. I'm going to show you in a second. I'm going to put some new numbers here. We're going to walk through it. But oftentimes the casino uses time as a factor to slow you up, particularly if you have a progressive style bet, because most people use progression style bets to accommodate for losses. And when you understand variables and algorithms, then you know you can maybe bypass a lot of that. And that's what I've come across over the last few weeks or so. So look, let's talk about, let me show you a video from the University of Khan Academy. I saw this video on YouTube. What I'm going to do is I'm going to let it play. I'm going to chime in after it. Once it's done, I'm going to show you the algorithm. Not show you the code, but I'm going to show you how algorithms in the game of roulette works and how you can win. Very much like playing the stock market, like this index. In the stock market, I talked about this previously. This is just like an index here. Let me see. Before I play this video, let me just go here. Real quick. All right. This is very much like an index, except the index in this case, as you can see, all of these are spins. This is all the way up to 700, all the way to 1,000. So the case study here is pretty intense. It goes all the way up to 1,600 spins, right? So if you look at this, and right here is $1,000, $2,000, $3,000. On this set of play, we would have won as much as $5,500, right? I think we never went below zero. This algorithm kept spinning the game upward and upward. Of course, you have some areas where it dips, but it generally rises back up and stays up. It might have hit a high here. I'm sure, if we play this longer, it'll probably spiral back up. But the game, as you can see, when it starts to do stuff like this is the algorithm working and kind of stabilizing the what the game is giving us, which is why you constantly see these increases. But what I was going to say here is that this constant flow of it going up is nothing but the algorithm at work. And but anyway, you know what? Let's do this. Let's just show you. Let's talk about the video. I'm going to come back and we'll talk about why this is. All right. So let's just go. And while this is going, I'm going to interject while she's talking. I may pause it. I'm going to interject some things about algorithms. Then we'll come back and I'll show you how roulette versus anything else, any business, any stock market, anything index wise is the better because it's limited. It's limited, it is limited. That's the only reason why I'm able to manipulate this. You can't do this in the stock market unless you know the variables. Okay, I could put a whole new algorithm in here and we would lose. This will be a downward index spiral. Okay, this will go down, but it's going up on every single one that I create. Here's another one. They all go up. Why is that? Because it's an algorithm. Very similar to algorithms are like, you know what? Screw it. Here's the video. Let's just go because I'm going to continue to talk.
It's an algorithm. to accomplish a task. You might have an algorithm for getting from home to school, for making a grilled cheese sandwich, or for finding what you're looking for in the grocery store. In computer science, an algorithm is a set of steps for a computer program to accomplish a task. Algorithms put the science in computer science, and finding good algorithms and knowing when to apply them will.
All right, and finding good algorithms and knowing when to apply them. The reason why algorithms are, well, first of all, she talked about it being a set of rules and a set of equations or calculations to solve a problem. Okay. And knowing when to apply those sets of rules is really key. And in discovering this game, I had to discover all of the 36, 38 variables of the game and understanding that. And so when you look here and you're able to decipher the patterns of the game, which is almost like an algorithm of like with you, like you have an algorithm of your own. Every time you get on Google, Google has an algorithm that follows your patterns, and based upon your search patterns, it offers you certain things. Well, the algorithm works and wins when you decide to click on stuff because it's following your patterns. Okay, so this is the same thing with roulette. It's just following the the numeric patterns, and instead of playing the numbers, you're playing in dozens so that you can save time. Because some casinos might try and crush you using time against you. Anyway, so let's go back to the video.
Will allow you to write interesting and important programs. Let's talk about a few famous algorithms. How does
Outside of the roulette winning one.
Google Hangouts transmit live video across the internet so quickly? They use audio and video compression algorithms. How does Google Maps figure out how to get from Dallas, Texas to Orlando, Florida so that you can get to Disney World? They use a route finding algorithm.
Okay, let's stop right here. Okay, a route finding algorithm from get to point A to point B, right? The same type of algorithm that's used in a GPS is the same type of algorithm that we use in the roulette game. It's a route finding. For example, in the GPS, if you're trying to go from New York to Miami and you veer off course, it will reroute, right? So it's going to create a new. The algorithm is going to be based upon where you are in your journey. Same thing with the roulette game. When the game is giving you certain looks, like if it's showing you a certain group of numbers, according to the algorithm will adjust to accommodate what's happening in the journey to get to a win. This is the reason why it's always spiraling up. So you can look at this downward spiral somewhat as a detour. Like if you were driving and you made a left instead of right, this is kind of what happens, and then it will correct itself and get you back on the right path. That's the whole concept of an algorithm. Like there's a in the RNG world, this there's an algorithm that works. There's an algorithm that works this. It's built to find out your patterns and it will counter your patterns. We're doing the exact same thing, except we're doing it against the game. And when you're doing it live and you got one ball, one wheel, but 100 different players, what algorithm does the casino have to fight off you? It doesn't have one. The only thing that can beat us is RNG because it uses an algorithm against what we play. Okay, so what we're doing is we're creating an algorithm as the game evolves in a very a fluid manner in which it's the ball the chances are not limited to some type of computer software. It's actually a free flowing game. All right, so let's continue.
How does Pixar color a 3D model of a character based on the lighting in a virtual room? They use a rendering algorithm. How does NASA choose how to arrange the solar panels on the International Space Station and when to rearrange them? They use an optimization and a scheduling algorithm.
All these algorithms that are used to on Google, Bing to find you, uh, algorithms that you use to do different things of your own. They all lead to solve a problem, but they're all based around patterns. That's the concept of permutations. The only reason an algorithm is what it is because it uses differences in patterns. Okay, she's going to talk about that in a second. So just keep that in the back of your head.
Those algorithms are more complex like making a grilled cheese sandwich.
And the reason why they're complex is because of the variables. The reason why the roulette game is complex, but it's not as complex as business or or say like the stock market. When I talk about analyzing risk, I'm talking about looking at the variables to notice differences, all right, to notice patterns. And the algorithms that you use, a flat bet algorithm that you use to pretty much find the rhythm of the game and use it against itself. The only way to do that is to understand all the variables that lie within it that creates that certain pattern. In business, there are patterns that are happening and variables that are being used against you that you can't calculate. Race could be a factor, sex could be a factor, uh, freak accidents could be a factor, banking, financing, credit. I mean, legal stuff, a new company coming into town with 10 times more marketing power than you. All of these are factors that affect your bottom line. In the stock market, if you use this as an index, for example, let's assume this was an index. Well, you can't control the variables that make it go down. Now, we can't control it whether it goes down, but what we control is the actual variable system to force it back into our favor because again, the game ebbs and flows in certain patterns. Once you get a picture and understanding of that, then that's when you can force the game back up into a certain rhythm. The game can't produce, it can't go say hit the number nine, 20 straight times. It's never done something like that because it's not rigged, okay? Unless it's of course RNG, but but other than that, if it's a real will, it will not do that, and because it won't do that, we have an algorithm that says we know you're not going to do that because of the variables and the way that the ball is being spun, blah blah blah. Because of that reason, we're going to make an educated bet that you will not do this based upon your pattern. And as you can see, even when we're wrong, it spikes back up in our favor because the game has to flow in a certain direction. Whatever that direction is, that's the way it's going to flow. We just have to be wise enough to pick it up, and that's what the algorithm does. That's the whole point of an algorithm. It picks up areas of your play or anything that you're doing to solve a problem.
But they boil down to the same thing, a set of steps to accomplish a task. If you know something about existing algorithms, you can save yourself some effort and make your programs faster by
That's the whole point. Is about speed. A flatbed system that we have makes playing faster, obviously more financially safe, but it's a lot more faster. And so algorithms help create speed so that you can get to point A to point B much faster.
applying the right one.
And applying the right one, you can have algorithms, but you can have the wrong one. And instead of having a positive progression, you will end up with a negative one. So that's where you got to study the variables. So everyone starting a business or everyone who has an idea of being a stock trader, they don't know everything. Most people fail because they can't calculate their risk. And that's the reason their algorithm, their abilities to accomplish a goal or to defeat a market or to dominate a market. You've got to know all of the variables that lie. When you don't know that, you can't appropriate the right algorithm, and of course, you're going to be doomed for failure.
For example, let's say that you're writing a game and you want the user to be able to play against the computer. Well, you could look at
Okay, this is RNG she's talking about. This is what she's about to talk about is exactly what this is right here. Okay, it's an algorithm.
checkers games for inspiration. Computer scientists have figured out how to write checkers programs that never lose by using the minimax search algorithm to search through the huge tree of possible moves.
Okay, if you go back and listen to my videos, when I talk about permutations from a perspective of possibilities versus probabilities, right? It's all possible. What algorithms does, as she's showing you, it goes about all of the most possibilities. But when you have a system code, it does it in a second or less than a second. So that's the reason why the computer always beats you, because it's going to go against you based upon what you've done, based upon the math. Okay. Well, in a real world setting, it is just a ball and a wheel. So it can't do that. So instead, of you're becoming the algorithm to a live game by using a certain code that I will show you in a second. Within your play, and it's all a flat bet. So instead of making a progression, you will make an algorithmic change. So let's say if you are playing and you say, "Oh wow, it seems like I'm down, a couple dollars." Well, instead of making a progression, you make an algorithmic change. It's the code that needs to change, not the money. So you don't throw more money at it. You actually change the code. Okay, so this is just in the mentorship program. This is not the other stuff I have. It's great, but they're all based upon progressions in which you're going to have multiple, and you need to take your time. This one I'm talking about defeats the game from a perspective of algorithms. Like you can't lose. You can't lose because the game has to go up. Otherwise, it's your algorithm that's wrong, and that's where it's taken all the time to actually find the right algorithm. So let's go.
If your game is similar to checkers, then you might be able to use algorithms based on these techniques. Then knowing the limitations of those algorithms might lead you to redesign your game if it requires having a skilled computer player. It's
Okay, hear what she said. Knowing the limitations. Let me rewind this. You guys got to get this. All right. Let's see. I want you guys to hear. I hope you guys heard that because this is where understanding variables comes from.
these techniques. If not, then knowing the limitations of those algorithms might lead you to redesign your game.
Okay, knowing the limitations of the game of roulette helps you redesign your game. When I started to study variables and risk, this goes for everything you do. Everything you do in life is all about understanding the risk of it so that your outcomes are favorable. When you understand the risk variables of this, every single number is a risk variable. Okay. The thing of it is though, is that they create patterns. Okay. They create permutations when you look at them enough. Go back in other videos. I literally I'm almost at a point where I was showing you guys where the ball is going to land next because it's a rhythm that happens here. If you have a fan that has like 5 or 6 blades and you ran it at a certain RPM, if you listen to it, the rhythm of the sound waves change, even though it's at the same speed and only has 5 blades, because the sound waves change. The algorithm that forces those changes, they change. Okay, so just because you have a singular outcome or singular, like you just have 36 variables, just know that these variables create multiple permutations and multiple patterns. The same way a fan that turns, if you listen to it, the actual turning becomes inconsistent. Okay, so it all produces, you know, a different pattern. Let's go back. All right. So yeah, based upon your knowledge, you can redesign the game and make the game, and you become an ace of the game instead of the game beating you.
If it requires having a skilled computer player. It's also important to know how to design new algorithms, as well as how to analyze their correctness and efficiency. In the biological sciences, new algorithms are continually being designed for purposes like designing the molecular structures that are the core of disease fighting drugs. In physics, algorithms simulate climate and weather patterns, and other algorithms search and analyze the vast data about stars in the universe that's collected by automated space telescopes.
What they're studying when they're looking at in space like this, they're looking at the patterns. They're looking at how many times a star flashes or twinkles. They're looking for all the differences. And based upon these differences, they detect constellations and universes and different things like that. But the algorithm is looking for variances. In the world of roulette, there's not that many. In the business world, it's almost uncalculable. In the stock market world, speculation, you can't calculate that. You can't calculate what's going to force what's going to force the stock down and continue to go down. The game of roulette is not. It won't ever just continue to do one singular thing. Okay, it's not built around that. It's really a free flowing when it's live, not RNG. When it's not controlled by a computer, it's really a free flowing thing, and that's the reason why the algorithm that I have is unbeatable.
Across all the sciences, and even on websites like Khan Academy, efficient algorithms are needed to analyze huge data sets or to select intelligently from a vast number of possible decisions. In just about any area you might be interested, new algorithms will allow massive computational power to be harnessed to do things that people really need and care about.
Absolutely.
Now, not all algorithms are created equal. So, what makes a good algorithm? The two most important criteria are that it solves a problem and that it does so efficiently. Most of the time, we want an algorithm to give us an answer that we know is always correct.
Absolutely.
Sometimes we can live with an algorithm that doesn't give us a correct answer or the best answer because the only perfect algorithms that we know for those problems take a really, really long time.
All right, stop here. So let's talk about the game. Remember, if you were doing certain strategies that we have, they're all algorithms, but they're algorithms that are based in progressions. And the progressions is really what kills you, not the algorithm or not the process to win. So in flat betting, we just take away that. That's all that happened, really. It's just we took it away, but we centered it around the nature of the game. And what makes a good algorithm, like she was saying, is its efficiency. Okay, your abilities to do things faster, and also the correctness of the algorithm. The algorithm that we use, it always puts you at an advantage. Every spin has you have an advantage in every spin. You have a couple advantages. Number one, because it's flat bet. And the reason that it's flat bet is because it's based around the nature and the patterns and the movement of the game. So we move according to what the game does, not necessarily what we want it to do. So the game can shift, we shift with the game. Okay, so that's how we have to learn how to create and have more an efficient algorithm when you understand that it's all based upon correctness and efficiency. The more efficient you can get, the better it is. But it doesn't necessarily mean it's the best because sometimes they do take longer because it's just like a GPS algorithm. If if you veer off the course too far, it might tell you to proceed to the route before it picks it up. Okay, that's an algorithm that says, well, you've gone too far off the course. We can put you back, but it's gonna take more time. So, for example, if you notice a certain downward spiral and if you don't correct the algorithm, because you don't have to use money to do this, right? You're not fighting it with money; you're fighting it with algorithm. But the game will show you just in your losses what's going on. So it's an algorithm issue. If you don't change it or if you don't turn around, then it could potentially lead to just a consistent downward spiral. However, the nature of the game is set that it will always spike back up. It will always do that. But you can save a lot of time in understanding the algorithms, and you don't even have to sit there and live through this. It will, it the algorithms that we have now, they always will spike itself back up, like you see here. And then on top of that, the key will be is to really once you hit like a $400, $1,000, is to just take your money and walk. I mean, you could stay, but the thing of it is that why stay longer? And if it does start to spiral down, the only thing you have to do is spend more time in terms of recovery. You don't have to spend more. You don't have to make any progressions. You have to spend more time. The game will recover itself because it's an algorithm. Okay, it's based around a limitation of variables. This is the limit. Okay, so but I'm gonna show you that in a second. So let's just finish the video.
For example, let's say we want a program that would determine the most efficient route for a truck that delivers packages, starting and ending the day at a depot. It would take weeks to run, going through all the possibilities. But if we're okay with a program that would determine a route that's good, but maybe not the best, then it could run in seconds. In some case, good is good enough. How do you measure the efficiency of an algorithm? We could time how long it takes to run the code, but that would only tell us about that particular implementation in a certain programming language on a particular computer and just for the input it was given. Instead, computer scientists use a technique called asymptotic analysis, which allows algorithms to be compared independently Some algorithms are more efficient than others. Now you can learn about algorithms and asymptotic analysis on Khan Academy.
Asymptotic analysis is kind of what we're doing here. Um, but we're doing it on the randomness of the actual wheel, an unbiased wheel, okay, where the wheel is not controlled by software. So, because that's the case, it's like in this case, you can see where was just pretty much a case study. And so we know that the algorithms are true to form because they constantly give us the certain type of increase in our profit model. All right, so let's just show you real quick and then we'll be done how this works. All right, so as you can see here, you can look at the charts. These are all play charts of 50 games. You can see 1 through 50 spins. This is the amount of money, so it's like up to $900. You can see this thing continues to rise. I'm gonna do a few studies of this, maybe 3, and you'll get a chance to see the algorithm at its work. All right, so here is basically the setup here. And what I'm gonna do is just copy a cell of random numbers that I've been using rather, and in some of my studying, let's take this one so that you guys could see it. So this is all kind of a lot of stuff that I've been studying and playing around with. But these are random numbers that I used. And we're going to use this in this case study here. As you can see, the moment I put this in here, it already had produced whether it's going to win or not. So this will be considered spin 1, 2, 3, 4, so forth and so on. Now, when you're playing, though, let's say you play number 8. It's the algorithm will tell you what to play next. That's the reason why it's already inputting the field. So what I want to do is show you the line graph when what this looks like in terms of the pie chart, or the as I call it, the stock indexed. All right. So this is the index to what this looks like. Let's look at the escalation of let's just look and see what this looks like. All right, as you can see here, we start at 100. It goes down a little bit, but you can see the spike up. You see the consistent spikes up like this. This is where the algorithm wins, despite whatever the game has given you, because it's all built around. Listen, the game produces a billion permutations, but every single spin, we're forcing the game to give us what we want, or we could opt out. Even in cases like this, where you have multiple losses in a row, you can make a stop loss situation where you say after one loss you don't play after 2 losses you don't play. That's $100 you'll save here, and in here it's $200 you'll save there. Let's look and see what that looks like on our numbers. Drastic difference. I'm not gonna say drastic difference. We were already up in the money, but at least in this case, even if we played it, it wouldn't have mattered because it's a flat bet and the game was going to produce the anomalies that we need for it to make a rise. What you should do, though, is when you're playing it, when you get to a certain point, you pluck out your money and you stop. I mean, you can continue to play. You can play it day in and day out. It doesn't really matter how long you play it. I'm going to give you an example. The one of the games that we did this algorithm into, it was quite a long game. And just to give you an idea of how long it was, 1,630. But as you can see, if you look at what the algorithm did, it started here at 100 and it continued to spiral upward. Okay, that's a positive progression single flat bet algorithm that works regardless of whatever the game gives you. This is how it works. All right, so I'm gonna do a couple more little case studies here. I'm gonna copy this and let's put this here. And I'm gonna see if we can get something that can give us a somewhat of a down spiral, and I'll show you how easy it is to combat losses in a flat bet algorithm. All right, so I'm gonna copy this. It's really difficult for this game to give us anything that's really hard to lose, to be honest with you. All right, so let's just do a line chart for this 50. Just gonna copy this. Oh, it's called a waterfall pie chart. Well, it's not really a pie chart. All right, so let's go here. For this set of 50, let's look and see what it looked like. So spin number one, I think we took a L right here. As you can see, when I hover the mouse over there, it says series 1.24. That's spin 24 minus 100. So we lost 100 there. It's okay because you can see the steady rise the algorithm creates. Even when it does this, that's fine. Because the game, sometimes the game is just like, again, it's like a GPS, a finding route algorithm, that when the game starts to go in a certain chaotic mode, it will counterbalance itself until it finds a certain streak, and it will just increase your money on the streak. Or like I said, you can, once you get us to a certain point, you can just cut it off. All right, so I'm gonna do two more. And as you can see, these numbers are changing. So just know that. All right, so I'm not hissy fitting with you. All right, so that's two. So all of this stuff, man, is just nights and days of analytics. All right, and maybe years, I guess you could say. All right, so as you can see, man, this thing, the algorithm is just so freaking strong. It's given us a steady progressive rise in our wins. Look at this. It all looks the same, doesn't it? Look at this. Look at how it does this. So look at this. So we had a downward here, but you can see the steady rise all the way up to almost $1,200. Okay. Numbers don't lie. People do. You have to have, see, all of this is just lines and lines of code. Yo, this is just wicked. All right. That's not what I want. Let's go back. So yeah. All right. So I'm going to do a couple more lines. As you can see here, pretty much the same outcome. It's all a positive progression algorithm. Let's get another set of numbers. So this is like 29, 12, 15, 20. You got it right. All right, so I'm going to copy that. We're going to insert it into our algorithm worksheet. I know it sounds corny. All right, so this one might be kind of cool. Let's see what this looks like, because it gave us a lot of, seems like we have a lot of zeros. I mean, have a lot of negative. But that's okay. I'm going to show you if it even does it. If it even, all right. Oh, good. Okay, so let's look at this. This is what I want you to see. All right, so remember where I was talking about, like, the algorithm works like, say, oh God, what did I just do? Oh, like if you were driving like a GPS algorithm, if you're driving and it veers off course, the things that you can do to bring it back. Well, this is in a small span of, sorry guys, I'm not sure exactly why this thing is blinking like that. In a small span, so this is just a 50 spin set. So let's say right here, we could have saved money here. We didn't have to play that. We could have probably not played that or that. But as you can see here, even though we saw this spiral, the algorithm picks it up here, and it kind of stabilizes you to bring you back up. Okay, and then had we played a little longer, would have came back up. So that's the thing about it. This is like a worst case scenario, and even in the worst case scenario, you can make a choice as to whether you want, like, after every, like, if you lose a set or lose a spin, then you simply don't play the second spin just in case it has a second loss. So that's $1, 2, 3, 4, $500 right here alone we would have saved. I'm give you an idea of what that looks like. So let's just assume, like, after every loss we didn't play, what this looks like. the numbers change drastically. All right. So if that was the case, even if we're being really fair, let's be fairer than that. Let's be fairer than that. And what I'm saying in terms of being fair is, let's say we didn't play, but we waited for a win, and then we start to our replay. That even stagnates this thing even more. And as you can see, when we started to come up, we came up as high as $300. So that's like you'll never like a consistent set of losing. You'll never have that ever. You'll never ever have it. As a matter of fact, like I said in the contract in my mentorship program, there's a 60-day um, ironclad contract that says if you can disprove this in 60 days, you pay nothing at all. You can't disprove it. You can't. That's the only reason I have that in my contract. It's because you can't. Numbers don't lie. All right. So let's see what this looks like. All right. So this was a new. Let's just look and see what this graph looks like and see what areas in which we could, or maybe if we even need to, make adjustments. All right. Nice one. All right, I'm going to show you how in algorithm world this works. All right. So in this case, it's the same kind of thing. You can set a stop loss. So if, let's say, if you're playing this, and the only reason you do this, you would do a stop loss, is because of time. It's not so much that this won't come back up. This coming like this, as hard as it looks, you can evade that. So for example, like if you lost this bet right here, you don't play the second. Anytime you lose, you just don't play until it wins again. So this is $200 saved. That's $300 saved. $500 saved again. Just even if you just did that. But assuming that you just didn't do it, right? The only thing you have to do is just continue to play this out. It's going to rise back up again. This is just 50 spins. So at the end of the day, even if you didn't do this, even if you didn't do a protective measure, and you just flat betted the whole thing, right? Regardless of what happened, it will rise back up. It will have to rise back up. So that's just the thing. But the reason why you would do that stop loss like that is because it saves time. Okay, because if you take that away, as we saw earlier in the other expression, how it ended up looking like this. And by the 50th spin, you were already at $300 because you did the stop measure early. Like when it lost, you just didn't play it, so you saved that $200 if you were betting this way. Okay, so that's the thing about it, is that it can, like all algorithms work, it's just that when the patterns change, just like your patterns change on Google, the algorithm changes. And then it bends into the favor of the algorithm according to your patterns. Okay, so in this case, the pattern is what it is, but the algorithm would certainly catch it. Like right now, right here, it was about to start to stagnate it, and then it will rise itself back up. All right, so let's look at a couple more, and just to solidify the point. Actually, you know what? Let's do this. Let's just look and see what this looks like if we played it the way I'm talking. All right, so we take that out. We take this out. Take that out. Take that out. And as you can see, the expression begins to change drastically, and you don't see the negative fall. You actually see an increase. But if we were being fair, we would take this out. We would take that out, which is fine by me, because there's just no hope for the game anymore. Guys better get with me quick, man. I swear to God, you guys better get with me quick. All right, so even if we were being fair about this, this is what it would look like in fairness if we were being conservative and played it fairly. This is where by the 40th spin, you're at almost $500 again. All right, want me to do a couple more? Sure. Hope you're having fun. This is the most fun I've had. It's so much fun when you've got something this cool and you've got your hand around it because you've done a diligent job at studying it. There's only listen. The only reason I even gotten this far in life with doing something like this is because of failure. I failed so much, and I've had so many things go wrong that it forced me to be great, and I had to be great, greater than the greatest great can be. All right, so just looking at this, I can see now areas where we could have. Look at this right here. See, we don't have to play that. We don't have to play that. Have to play that. So let's look at it the raw. Let's look at it raw and uncut, and then we will make our adjustments. And again, when you're playing this, you're going to be adjusting on the spot. So you're not looking at a spreadsheet like this. I'm just showing you what the overall landscape looks like in the end. But on the spot, you will be making adjustments for this. And also, too, I will show you if you do decide to come aboard the mentorship program. I'll show you how to do this. Well, you'll get the calculation, but I'll also show you how to do the pie charts and stuff. All right. All right. So as you can see, in terms of the algorithm, there is a downward spiral. This happens. Any algorithm, anything that changes in terms of code or something like that, as often as the roulette game does, you can expect this to happen. This does happen, but you can evade this. But this is what happens after the game catches up. Like certain algorithms that the game gives you or permutations, they can extend for spins. So, but there's just has to be a way where you capture it. Well, how do we do that? Well, we know what our algorithm is. So if we lose on the first one, we don't have to bet the second, third until we win. So let's just do it the way we would have played it. Oh, wow. Look at the numbers are changing that fast. They're changing. They're changing. They're changing extremely fast. They're changing. It looks like we're not playing much, but technically we are. And, and that should do it. All right. So this is what we look like if we played this where we evaded all of the losses, right? Well, we would have gotten down. This is $100 bets. Every bet is in this case is $100. So we would have only been down 5 spins. But toward the end of the 50th, this was making its way back up, and we are a little over 100. If we continue to play this out, trust me, it goes way over $100. So this is like your worst. This is your worst case scenario. But I'm not even talking about progressions you can do with this. Like you can make other progressions that are just dynamite. All right, let's try. I'm gonna do one more, and then the case study will be over. But this is good. This is so indicative of the market. It's just that you are able to manipulate it, knowing that the market changes. The variables they're so limited that you know you're gonna come up against this. It's just how do you evade this? Either you don't even really have to play it. You could just watch it spiral or just play along with it. And if you lose, just don't play anything after it until it wins again. If that doesn't make any sense, if you join the program, it makes all the sense in the world because it has to. I have to make sure you win because if you're winning, guess who else wins? Me. All right. So let's do one more set of numbers. That was a horrible accent. All right. 13. Let's insert it here. See what, all right, so this really didn't give us any fuss. So this is kind of an easy one. And I'm sorry that the video is this long, but it's really cool stuff. All right. Yeah, this should definitely be a positive one, and it is fairly for the most part. And as you can see here, this is kind of what I was trying to hint at earlier about if it spirals down, the algorithm corrects itself, even if it does spiral. Like in the case that you saw here, the correction just came after the 39th spin. But there's things you could have did to save some money. Like technically, you're only down 5 spins on this example. But here, it's kind of just depends on where the game starts or where the numbers are. So in this case, it started here. You could have stopped at 300, took your money. Oh well, I'm just continue to place here. Oh wow, it's starting to go back and forth. And as when you start to see this rise, you'll notice your money rising. You're at 200, but the goals is up as high as 700 once it gets outside of the algorithm storm. Once that happens, then it just rises out. But it will fight the algorithm does fight the game extremely well. And then there's things like I said that you can do that I need, like, again, I haven't even talked about progressions you can make. This is ridiculous is what you could do. Anyway, guys, this is what I'm doing now. This is the new mentorship program. It's all steeped in flatbed algorithm that is completely undeniably undefeatable, if that's such a word. The reason that the reason why it can't be beat is because it's based around the nature of the game, and the algorithm picks up the nature of the game. Even if the game is giving you losses, the way that the algorithm set up, you don't even have to play them. Okay, so you don't have to play through the game, and you never have to make a progression. All right, this is the only way to beat the game with one strategy. It's the only way to do it that I know of. The other stuff that we do, we teach. You can do. Oh God, you can make a lot of money because that's how I made money before. But it's certainly one that you can't sit there all day with. Something like this, you can be here all day with it. The question is that when it does go down, do you want to stay around and wait for it? This is for people who, if you've got money and you want to be successful really, really quickly, come join, because that's exactly what I want you to do. Again, it's a 60-day, no fuss. If you can prove this wrong in 60 days, you get your. I give you 60 days, day in and day out. I got you 60 days. All right, so that's a guarantee for me, because you can't. And the reason I say you can is because the game will run into a syntax error in which it's impossible. Even if it did that, you don't even have to play it, which is why when it starts to get outside of the algorithm expression that's in limbo, it will spike itself right back up every single freaking time. All right, guys. Hopefully this was enough, and hopefully it wasn't too long, but hopefully it was educational. If you want to join the mentorship program, I still have spots available, and it's pretty tough. You have to be here to make money. We're gonna make a lot of money. All right, that's the only objective, to make money and to do very well, and ultimately you can start to mentor 20 people of your own, and we all make a lot of money, because the game can be and is being defeated using flatbed algorithms. Okay, we've been whooping the game with progression algorithms, but this doesn't require any progressions. And that's the reason why we can weather any type of turbulence as it relates to the algorithm. Okay, the efficiency of the algorithm. Good is good enough, as the lady said, when you're talking about algorithms, because things change. They change frequently. This is better than business. This is better than the stock market. Debate me. Tell me I'm wrong. Show me that I'm wrong with this. Show me that you can calculate your stock index better than this. Show me that you can calculate risk in any business better than this. I'm open for it. I'm open to hear it. I'm open to hear it. And anyway, folks, till the next time, guys. Hopefully see you soon. Permutationspro@gmail.com. If you're interested, hit me up there. It does cost. Yes, you do need money, but yes, you're going to make a lot of money. All right. So, but if you want everything that led me up to this, I'm doing a bundle package, including all of the numbers, like the numbers that I showed you where you can actually depict the next number coming up. I have a system like that where you know what's coming up between here. I'll give you all of that, including Alice in Wonderland, which has been a big hit for the last 2 years. You'll get that all in a bundle package for $700. It's like a $2,500 package. You can get it all. The only difference that you don't get is the mentorship. If you want the mentorship, that's different. You just have to hit me up on email, and that's where it's you get me. I literally work for you, and there's a upfront charge, but then there's a 30% back end charge on everything you do. You just have to be diligent, but we do have legal safeguards to find out who's not being diligent. Okay, because if I ever have to go to court, I have to prove this. Okay, and reasons why we have contracts is so that I, we we have to prove them. Okay, so so that's just the deal. It's like we have to also safeguard the program for those who are joining, so that we can keep this for a long time. All right. Hopefully, this gives you some insight into algorithm expressions and a little bit about permutations, I guess. Until the next time, folks. Take care. Talk to you